Have you ever smelled a candle that reminds you so much of home that it almost feels like you're there? Or does the smell of warm, buttery popcorn take you back to the movies at that awful first date you had? Well, the sense of smell has a unique tie to memories, specifically emotional memories. Why this happens is because of a wild phenomenon involving the pathway of these neurons to the brain. If the word neuron was enough to scare you off, I hope you stay for just a little bit longer because I'm going to try and explain this using a visual that's a little more easy to understand. The game of telephone. Imagine a single neuron or cell of the nervous system is a player in the game. The first player who chooses the word to be said down the line is our beloved sensory neuron. These are specialized cells all over the surface of the body that can detect changes in the environment such as pressure or chemicals. Each sense has unique sensory neurons, and for smell, these are called olfactory sensory neurons or ORNs. This next player is called the olfactory bulb. This is a structure at the base of the brain to relay information to other parts of the brain. Here's where the game gets a little complicated. Instead of sending the message to just one player, the olfactory bulb decides to go rogue. For most senses, it takes a quick direct pathway from the sensory neuron to the thalamus to the cortex. The cortex is the last player in telephone who interprets the final message. Now the olfactory bulb takes its own route. Of course, it still sends messages to multiple parts of the cortex. The main recipient is the piriform cortex. This encodes a majority of olfactory information. Then there's the orbital frontal cortex. This is a part of the brain that connects different senses to make decisions. For example, if you smelled a piece of burnt toast, your orbital frontal cortex would be the part that would connect this to the bitter taste of burnt toast you once ate and tell you not to eat it. These are both typical paths in most senses. However, the olfactory bulb skips the thalamus entirely and sends information to two wild parts of the brain. One is called the hippocampus, which is the main control of memory in the brain. The sense of smell is the only one with this direct pathway to the hippocampus, which is why there's that strong tie of scent-based memories. But it does not stop there. The olfactory bulb also sends messages to the amygdala, which plays a big role in emotional memories. At the end of this game of telephone, these recipients of the message all work together to create your perception of smell. Now let's see if you can put this puzzle together like your brain does in a hypothetical situation. First, a chemical called cinnamaldehyde binds to the cilia of an ORN. This ORN gets excited, telling the olfactory bulb, "Dude, I got some cinnamaldehyde, go tell everyone else." So the olfactory bulb goes and tells all of his friends. The piriform cortex says, "Yep, this is in fact cinnamaldehyde. This is a pleasant scent," and it makes you consciously aware of what the scent is. The hippocampus says, "The last time I smelled this amount of cinnamaldehyde, it was coming from a cinnamon roll." The orbital frontal cortex says, "You enjoyed the taste corresponding with that smell. I bet you want another one. You should get hungry to prepare to eat another one." Then the amygdala says, "Oh, the last time I had a cinnamon roll was when my mom baked me some. I miss my mom." So at this point, you can probably collect that the smell is coming from a nice, freshly baked cinnamon roll, right? Wrong. It was from a candle you picked up to smell at TJ Maxx. But that's where the other scents come in to tell you otherwise. Thank you so much for listening to this lesson on why scents are tied to memory. I hope you learned something interesting and know to stay away from your ex's perfume.